So this is going to be a really interesting one. I'm gonna start with two things. First is thanks. So thanks to OCP for allowing me to come and do the presentation here. Bigger thanks to all of you and your perseverance. You're here all day long. I'm gonna get to the second part. That's the challenge part. So Murphy has been at work today. Murphy absolutely has been at work today. I am not the original presenter to begin with. The original presenter called me 6:30 in the morning, and his father passed away, so we had to fly to France. So I subbed in. It's okay, we'll sub in. We'll give this a best shot. Second thing that happens, we just find out less than an hour ago, my computer's dead. They've been trying to fix it for an hour. We've had no luck. The third, and a bigger Murphy, is I'm between you and your happy hours. So if any of you want to get up and leave, I'm perfectly fine with it. It's not gonna insult me or anything. I probably might do the same thing on you if you were being here. Two things we could do. I could just simply start with a call of action. I do have the presentation on the mobile phone, but I refuse to read that. It just doesn't make sense, right? We tried every which way to present, even from here, but it wouldn't work. So I'm not going to go there. I could talk through a couple of things, what we were planning to do, but as I said, I could start with a call of action. One is either I could take all of your cards or I could give you my business card. We will make the presentation available to you as we had put in the call of action to begin with, ending from the back towards the beginning, right? Again, apologies and great appreciation for you still being here. So our talk was supposed to be open compute is synonymous with open edge. And some of the things we wanted to talk about, and I'm going to go off just best as I can, touch all these areas. But before I go there, I'll introduce myself. I'm not Philip Michelet. I am Hitendra Soni, known as Sonny, that's my middle name, and I lead business development at a company named Kaloom. Kaloom has been around for 4 years, and this ties to the topic we're talking about. It's been built around entirely open from hardware perspective and completely open from software perspective. So what are we talking about? So we believe that as the networks evolve for the future, specifically edge, I believe all of you are looking at edge one way or the other. So the edge definition is a challenge, right? Well, what is edge? Is it a service provider edge where you aggregate all the different accesses and you put all the data pieces together, put all the applications and server from? Is it the edge at all the way at the customer prem? Some people call it far edge. Some people also call that far edge when underneath the cell towers, we're going to put some compute. Why are we doing all that? And one of the reasons we're doing all that is we're bringing compute and application as close as we can to the user who are going to use it. These are the new needs of the application. One of the words I've heard being said a lot is the data is just not centered anymore. Every which way you look at it, whether Gartner's predictions or anywhere you go look at it, it says that more than 70% of the data is going to be processed outside of data center, which means into the edge, whichever definition of edge is. So when you come to now edge, openness is absolutely needed. Openness, A, in the hardware. My previous presenter just talked about it, a white box, right? Now so the white box, we could talk about the compute, storage, everything you've seen out there. Same thing with networking. So white box and networking, we've been doing that for quite some time. One of the unique things we saw in doing that in white box also is, if you look at the ASICs from before, ASIC as in name states, application-specific integrated circuits, right? The ASICs moving forward were designed for specific function, and to change any of the functions really required you to change the entire system or entire box, if you will, that is the ASIC. So one of the things we really went on the open side is programmability of the ASIC, P4. Because the things are too open right now as you go towards the edge, where there is 5G related edge, where the whole 3GPP standards are still some amount under development. You take any which way, edge is kind of viewed as a kind of sort of a developer's platform, if you will, which means we're not going to be able to commit it down to the ASIC that will change. None of us are going to go. None of us are going to go and change the hardware every time I have to change the software. Just not a reality. And whether you're enterprise customer or service provider customer, right? So that's one. So we started with the P4 programmability. And P4 programmability is allowing you to access the capability of the ASICs and all the systems around it. May that be FPGAs to complement it, or maybe the Xeon processor servers to complement that. The idea is P4 programmability is needed for that insurance we need to do. So you got to be open that way from that perspective. Number two, we see from the openness perspective is network, because of how they were kind of siloed. So there's a compute, there's storage, there's application camp, and there's a network. Compute, storage, and networking have been siloed in the sense that some of the portion has moved over to the Kubernetes, first VM virtualized to the Kubernetes, and now we're all talking about Kubernetes one way or the other to make it work. Now, why should computer remain, or the networking remain the silos? What if the networking was to be viewed just as a compute? And what if we were to address networking same way we address server? Some of you may remember long time ago where Scott McNeely said a network is the computer or the computer is the network. It's synonymous from there too. So the idea there is taking the open hardware that supports the change as far as the change process and change of the processor types and change of the speeds, all that, and then take the open software. So what do we mean by open software? We believe that no one vendor is going to be able to deliver everything against what the requirements are today, or the requirement could be end of tomorrow, which means the ecosystems is going to have to work together. All the process, the OCP, and all these years have made it. We've been part of it for a long time. That's significant. You now take that next. Is your workload, your containerized or virtualized workload, should be able to run on any targeted hardware based on the need of their workload. So what do I mean by that? So far, we've done everything based on, let's say, the Xeon processor. We've scaled everything 3G, 4G, where a whole bunch of software is running on the server. The need of the 5G is going to bring us to a topic or point where we're going to need hardware acceleration. One might ask, okay, why? So go back to edge. So what's with the edge? Typically, it's going to be power, cooling, space, constrained area. Whether you're a service provider with a very small area and power budget to deliver something with, or whether you're an enterprise with a very small area to deliver a lot of services. If we do all of these, continue serving all the software and software needs with just the regular processors and CPUs and x86, we believe that cannot scale. It takes too much room. It requires too much infrastructure. So you need to be able to do hardware acceleration. So hardware acceleration is using the right hardware. May there be DPUs sitting in the server. May there be switches. In any of the area according to the workload needs. And as long as that's OCP compliant, that's what the software should run on. Okay. I'll watch my time. So what have we done? What have we done differently with this? We're working very closely with Intel, Red Hat, initially. We've come up with a unified edge platform. And the unified edge platform such runs the entire Kubernetes operating system as an OCP, in this case, OpenShift Container Platform, runs right into the switches. The switches come with the whole packet processing power of Tofino chipsets. It comes with a complement of FPGA because the ASICs, the things that move the packet very fast and very fast, they were not meant for high touches. So high touch is like if you're a load balancer application, you've got a firewall application. So you got to have very high touches. So do the high touches with the FPGA side of the business and then leverage your ASICs and a capability of the, let's say, Tofino 1 or Tofino 2 or Tofino 3 in this case. Leverage that for what they were built for. So now combining both the hardware and software together and giving a one single execution platform where all of the silos, compute, storage, networks, application, are addressed with one single execution platform. May that be Red Hat OCP, may that be any other distros of the software. So that's one thing. One of the things we wanted to come here and ask, if you are a hardware vendor that's on OCP side, or if you're a user of this technology, one of the things that we're looking at is taking it beyond, taking the Tofino 2 and 3 for 25 to 50 gig per port to 400 gig per port, and then complementing that with all these technologies around it. So if any of you have any opinion on that, we'd love to hear about that, on how do we take it to the next level where we deliver enough compute, storage, and networking all the way to edge in the most compact infrastructure that leaves all the room to deliver all the applications. Because if we can't serve any applications that are monetizable and use the entire infrastructure just for services, that does not make sense. Last note, and I'll shut up after that. So last note is this: you come to different functions. What are you going to do with different functions in the edge environment? Firewall comes from someone else. Load balancers come from somewhere else, like F5. Firewall from Palo Alto Networks, and all the different. How are we going to service chain all these capabilities together? Where as you move the packet around to serve the needs of the lowest latency applications, if you have to go through all this, how are you going to make that happen? So one of the areas that we're leading and doing a lot of work, again in open schema of things, is SRv6-based service chaining. What if we were to do the service chaining such where we enable all those applications, the capabilities of the open hardware and hardware acceleration to improve that performance, not only from performance perspective, but from OpEx perspective, where managing all the applications that you roll out become a lot more easier, a lot more simpler. So I'll stop here. Again, my apologies. No visual. Stand up for somebody else. And in between you and your beer, I do thank you for persevering and still staying with me. If there's any question on edge and an open part of the edge, hardware, software, any which way, where it is today, where it's going tomorrow, taxonomy, I'm absolutely open for any question. And if there is none, we can still go out and have beers together and talk some more.
Comment, I think you should look at OPI, Open Programmable Infrastructure. All the names you mentioned are also part of that. We're looking at how to leverage IPUs, DPUs, not looking at edge specifically, but how do you accelerate and how do we have a common API? That way, whatever you are building and the service chaining, we can definitely leverage. It will be good.
Absolutely, that's a very good point.
I don't have a question, it's just a statement.
No, when I went back to that, that's exactly it. If we're running our firewall, if you're running our load balancer, how do we do it such where you just do the first lookup and look under the header and look up the header, and based on that, you determine that this doesn't need to keep doing this round trip anymore, and you just pass it right through, and you pass it right through the higher processing. Does that?
No, I'm saying that whatever is the architecture in terms of service chaining or composability, it'll be good if you could join OPI and collaborate there. Just making it as a statement.
Got it. So whether service chaining in SRv6 or whatever, bring it into the OPI.
I would say because that will become a standard and can work. Hopefully, we'll get to a point where it works across platforms. And there are a lot of other folks with opinions there on how we should do. There is a way of, there are things about chaining things and there are things about service headers, right? How do you look at it as a hardened, there is no terminology for this, so I'm just making this up. So you could imagine set of services, and then there are sets of services, then maybe you chain them because you don't want to chain everyone. Again, people with opinions, architects from different companies, different perspectives. So some of what you're doing might benefit OPI, as well as you may benefit because you're saying you're doing it openly if you collaborate with OPI.
Absolutely. Well taken. Thanks. We'd love to exchange the cards and information so we can get that going. Anything else? Any comment, questions, suggestions? Thanks again. Thank you. Greatly appreciate your time.